Hello, dear students. Welcome to those classes once again. And today I'm going to discuss a very important topic, and that is relative permittivity. Okay, what we are going to discuss is the topic in NCRT in physics in NCRT book, lesson number first, electric charges and fields. So here the topic which we are going to discuss relative permittivity. In my previous video, I have explained you the Coulomb's law. And when we studied the Coulomb's law, we have considered there are two point charges Q1 and Q2 separated by a small distance r apart them. And what I have considered, I considered these 2 point charges. What we have considered? We consider suppose 2 point charges, 2 point charges Q1 and Q2. They are kept at rest and separated by a distance. Suppose 2 point charges Q1 and Q2 separated by a distance R. We have considered these 2 point charges are placed in vacuum, and they are placed in vacuum. The force of interaction that is going to be applied between them, I can write down when they are placed in vacuum. I can write FVACUUM. It means when these 2 point charges are placed in vacuum, then the force of interaction between these 2 point charges, that 1 upon 4 pi epsilon naught Q1 Q2 upon R square, that is the magnitude of the force when 2 point charges plus Q1 and Q2 which are at rest separated by a very small distance r between them. Okay, so I consider this is equation number first. Now I consider that suppose these 2 point charges are placed in a medium. Which medium? Let's consider the medium is dielectric. What is dielectric? What are dielectrics? Generally, insulators are termed as the dielectric. Dielectrics are those substances through which electric charge cannot pass easily. Okay. So, if I consider these 2 point charges, when point charges are kept in kept in a medium. Which medium? It is dielectric medium. In that case, I can write the force of interaction between these two F medium is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square. Once again, the magnitude of the force. Here I have write down epsilon. This is the permittivity of the medium. Here I have write down epsilon naught, that is the permittivity of the free space. Okay. So when these 2 point charges are kept in vacuum, the force of interaction between them is represented by equation first. When these 2 point charges are kept in a medium and the medium is the dielectric one, then the force of interaction between these 2 point charges is given by the expression F medium 1 upon 4 pi epsilon Q1 Q2 upon R square. Here I have to write down epsilon is this is the permittivity of the medium. This is the permittivity of the medium. Okay. So now what I will do, I am going to divide equation number first by equation number 2. When I divide, now F vacuum divided by F medium. Let us see what result we are going to get. I write vacuum 1 upon 4 pi epsilon naught q1 q2 upon r square, that is the sign of division. Write down here 1 upon 4 pi epsilon q1 q2 upon r square. Observe that that has been cancelled, that has been cancelled, that has been cancelled, and ultimately what you are going to get, I am going to get, that is equal to epsilon upon epsilon naught. Okay, so what I get, then I divide F vacuum. When I divide F vacuum by F medium, I get this expression. It implies that in next step I can write epsilon upon epsilon naught, that is equal to F vacuum upon F medium. Actually, this is a new physical quantity. This is known as epsilon r. It means relative permittivity. What is this? Relative permittivity of medium with respect to vacuum. With respect to so I can define the relative permittivity of the medium is equal to the ratio of the force when the two charges are kept in vacuum to the force of interaction when the two charges are placed in a medium at the same distance. Okay, in next step I can write down this epsilon r. The other name of this one is dielectric constant. This is dielectric constant. Or you can write down, let's see, K is equal to epsilon r, and epsilon r I have already told, that is equal to epsilon upon epsilon naught. What is K here? K is the dielectric constant, and dielectric constant is also known as the relative permittivity of the medium with respect to the vacuum. Okay, and so you can write down K is equal to epsilon r, epsilon upon epsilon. In next step, I can write down, it implies that K epsilon naught is equal to epsilon. Right? Now, this is a very important relation, and it has been utilized in many numerical and in objective question, and conceptual question may be asked also. So once again, that's the time for one conceptual question. Question may be asked like this one: what will happen if the two charges which are initially placed in vacuum at a certain distance, they are placed at the same distance in a medium? What will happen with the force of interaction? Let us see how we can write the answer of this question. I have here mentioned K epsilon naught is equal to epsilon. Now I am going to put the value of epsilon in equation number second, and let's see what result I get. So I can write here, I am going to write, therefore here I am going to write, first of all erase it. You see, when I place the value in F medium, what will be the F medium? 1 upon 4 pi epsilon q1 q2 upon r square. Okay, I am going to place the value of epsilon here. Let us see what is F medium. F medium will comes out to be 1 upon 4 pi epsilon naught k q1 upon q2 upon r square. So what I am going to observe, everything here is constant one. or I can write down it as this quantity 1 upon 4 pi epsilon naught q1 q2 r square. What is this one? This is F vacuum upon K. So what I have observed, when the two point charges are placed in a dielectric medium of dielectric constant K, then the force of attraction is reduced by 1 upon K. One more example, if the two point charges are placed in water, okay, distilled water, that is a dielectric, but ordinary water, that is a good conductor, that is a conductor of electricity. Suppose we have placed these two point charges, we can consider in any medium of dielectric constant 81. Actually the water has the dielectric constant 81. What will happen in that case? F water, that will be equal to F vacuum upon 81. It means when these two point charges are placed in distilled water, which is a dielectric one, then the force of attraction between two point charges reduced to 1 upon 81 times. So that is the utility, or that is the use of this particular formula, which can be applied to solve numericals which may be asked in objective form or in conceptual form. So once again going to revise you what we have learned today. We have learned what is what is the relative permittivity, and the formula of relative permittivity, epsilon r is equal to epsilon upon epsilon naught, and this relative permittivity is also known by other name dielectric constant K. And if the medium between two point charges is not vacuum, is a dielectric medium, then the force is reduced. So we can solve many numerical which are based on this problem. Thank you. Have a nice day. And if you have any problem, then send your comment in comment box. I will try to sort out your problem in my next video. Thank you very much.